Hey guys, welcome to another video for pre-calculus. We're still on 10.2. I'm going to be working out two problems, number 33 and 35. So let's go ahead and get right to it. So like I said guys, we're working out 33 and 35. Let's go ahead and jump into this. This is pretty involved. So this idea, number 33 and 35, we're wanting to find a quadratic model for each of these sequences. All right, so let's see what we're talking about here. So as you can see with 33, we're being given a sequence of numbers. And to find the quadratic model, I'm going to pay attention to my first three terms. These are the terms that I'm going to look at to find out what would the quadratic model, and when I say quadratic model, I'm talking about a quadratic formula, if you guys recall that from a while back. So as I said before, I'm looking at these two quantities, 12, 19, and 28. Right? So our main formula that we're going to be feeding off of, I'll write it in red at the top here. So this is the quadratic formula that we can use for this sequence. Okay, plus bn plus c, right? So our an, we can substitute our an for the nth value in our equation. So here I have 12, and then my first version of this equation would be an squared plus b. Now, as I mentioned before, I can replace my nth value in my n. So that means every time I have an n, I can replace replace it with the number of term that is. So 12, let me highlight 12 here. 12 is my first term, right? That's my first term, and then my second, and then my third. So knowing that, since this is my first term, I can replace all of my n's with 1, right? So let me go ahead and do that. So that's a to the 1 squared, and then b times 1. Okay. Now this is important because I can do this with each preceding equation. So again, this is an squared plus bn plus c, and then the same thing here, right? So you see that repetition, that pattern, and then my n's here can be replaced by whatever term this is. So this is my second term, so I'm going to replace it with 2 times 2, and then since this is my third term, you guessed it, I'm replacing it with 3. Right? And then I can just go ahead and go about simplifying these formulas, and I end up with 12 equals, excuse me, a squared, let me move it over a little bit, a squared plus b plus c. In fact, let me go ahead and change my order a little bit, and you'll see why in a second why I'm doing this. Okay, so this is a squared plus b plus c equals 12, right? And then my second formula is a, or 4a, right? Because if I look over here, 2 squared is 4, so that's a4, or 4a. And then 2 times b is 2b, and then plus c equals 19, right? And then for my third equation, I end up with 3 squared is 9, so that's 9a plus 3b, and then plus c equals 28, right? So hopefully you can see how each of these terms here corresponds with what I have on the other equation. So that's 3b, right? Okay, so if that's clear, then we're going to go ahead and move on, okay? So what we want to do at this point, is we can actually use, we want to find the values, we want to find out what a equals, we want to find out what b equals, and we want to find out what c equals, because these letters are going to represent my coefficients for my quadratic formula. So as you can see here at the top, my coefficient a, my coefficient b, and then c. I want to know what those coefficients are because That's what's going to give me the base quadratic formula. And as you can see here, I have three equations that have all three of those terms in it. Now, what we can do at this point is we can write this as an augmented matrices, okay? So, for example, if I look at the top row, my coefficient here is 1, 1, 1, 12, right? So my matrices would be 1, 1, 1, 12, right? And then for my second row, I have a 4, a 2, a 1, and then 19. So 4, 2, 1, and then 19. And then for my third row, I have 9, 3, 1, and 28. So 9, 3, 1, and 28. And this is my augmented matrices. Now, at this point, I can go about working this out by hand, but I can use my graphing calculator to help me solve this much faster. So, in my graphing calculator, this is what I want to do. I want to go to second matrix. I want to go to edit, and then I want to write that. I want to write what kind of. So if you can see here in my graphing calculator, I have this matrices is a 3 by 4, right? Okay, so it's 3 rows by 4 columns. And then as you can see here, I put down, I put down what my terms were in my matrices. And then I put all 4 terms all the way to where it says 12, 19, and 28. And hopefully you can see that. Hopefully it's not too dark. Okay? Now that I have that, in my calculator, I want to go to second quit. I'm going to go to second matrix again, and then I'm going to go to the math menu, second matrix and then math, and then I'm going to go all the way down to where it says RREF, and that stands for reduced row echelon form. Okay, so I'm going to press enter, and I end up with this. And then I want to go to second matrix again, and I want to select the one that I edited, which was my A, and I want to press enter, and you end up with this. And then you want to close the parentheses, and then press enter, and then this is what you'll end up with. Now, if you look at that last row, here, let me write out what I ended up with when I did my reduced row echelon, RREF. And then I ended up with parentheses, bracket, my matrix A, close parentheses, and then I ended up with, and my last row, well here, let me just go ahead and write it out. 1, 0, 1, 0, 1, 0, 4, 0, 0, 1, 7. That's what I ended up with there, as you can see. I hope it's not too dark. And so the row that I'm paying attention to is this last row, because this row is telling me the values for my A, B, and C. So A is equal to 1, my B is equal to 4, and then my C is equal to 7. Now this is important because now I can replace these terms with my terms up in my original equation. And my quadratic form, okay, the model for my sequence for a to the n, my quadratic model will be, since it's 1, it's n squared plus 4n plus 7c. And that is my quadratic model for this particular problem. Okay? All right, let's work out number 35 so you can see this at work again. So I'm looking at 35, and this is the sequence. It's giving me 8, 3, -6, -19, -36, and -57. As you recall, with the last problem, I'm only worried about my first 3. Now, I can do the other ones too, but since I only have 3 terms, A, B, and C, I only really need to worry about the first 3. So, recall that my base equation for the quadratic model is a to the n squared plus bn plus c. And again, recall that with my equation, when I'm at this point, I'm looking for I'm looking for linear equations with 3 variables, right? So these are the 3 ones. I want to simplify this. So my first equation will look something like this. So it's 8 equals a, and then this is again is my first term. So I'll replace my n's with 1. So that's 1 squared plus 1 times n plus c, and that's going to yield me on the other side. It's going to yield me with a squared plus b. Well, it says n, so I should say b, right? It's b times n, so that's my n times b. So it's going to give me b plus c is 8, right? So now for my second number, which is 3, that's a, and then that's going to be 3 squared plus 3b plus c, and that will give me 9a, right? Oh, I'm sorry. Let me go back. I hope you caught that mistake I made here, because remember, you're supposed to replace n with whatever term this is, and this is my second term, but I replaced it with 3. That should be 2. So I hope you caught that. I guess it's a good thing that I made a mistake, because, you know, we all make mistakes, and now you can see what can happen. So you got to be careful and not go too fast like I was. So it's going to be 2, 2. So it's going to be 4a. Do it in green. It's going to be 4a, right? Plus 2b plus c equals 3. And then for my third one, it's going to be negative 6 equals a 3 squared plus 3b plus c. And that will yield me a 9a plus 3b plus c equals a negative 6. So what I want to do now is I want to write this in a matrices form. So that will be, this will be a 4 by 3. So when I go to my calculator and plug it in, it's going to be a 4 by 3. So it'll be 1, 1, 1, 8, right? Because that's 1, 1, 1, 8. And then my second row in green is 4, 2, 1, 3. And then my third row is 9, 3, 1, negative 6. And that's my matrix. So then I will go to my calculator. I will go second matrix. I'm going to go to edit, and then I will plug in my terms. So 1, 1, 1, and then 8. And then 4, 2, 1, 3. Then 9, 3, 1, negative 6. Enter. Okay, so there it is on my calculator. I have a 3 by 6, I mean a 4 by 3 matrix, right? And so now I go to second matrix. I go to the math, if you recall, math, and I go all the way down to my reduced echelon form. Okay, enter. Whoops, back up. Quit. Second math, and that's going to be my B. And then I go back again, second matrix, and then I choose my A, close parentheses. So it'll look like this, right? And then enter, and there it is right there. If you look at that far right row, that'll tell you what your terms are. And I'll write it down here, so that's what you have on the screen. So I'll write it in gold there. RREF, parentheses, bracket A, bracket, close parentheses, and these are the terms you have. You have 1, 0, 0, negative 2, 0, 1, 0, 1, 0, 0, 1, 9. And again, I'm paying attention to this last row because that gives me the value of my A, B, and C. So A equals negative 2, B equals 1, and then C equals 9. And so now I have the values I need to write my my quadratic form. So My quadratic form will be a to the n equals negative 2n squared plus n, because it's 1 there, and then 9 plus 9. Okay, well, that does it for this video. That's number 35. This is my quadratic form, and I hope this helped, and good luck in your studying.